Alright, brace yourself for my awesome, extremely professional presentation. Here we go.
Alright, so, this is Catie Lynn, and here we have the lac operon. Ooh, I forgot. This little, squirrely thing is the DNA inside. It's just showing the DNA, And then, this is the promoter, this is the operator. The promoter is just, it's basically where RNA polymerase is going to come, to start the whole thing. It's basically what tells the RNA polymerase. It's basically the starting line, I guess you could say. The operator is going to be this little guy where the repressor, this orange thing, is bound to or not attached to. I mean, the repressor can move on or off, and I'll explain that more later. The repressor is, if it's attached to the operator, it's going to affect what RNA polymerase does, and if it's detached, it's going to affect that. So since this is a lac operon, oh yeah, and all these over here are the structural genes. Since this is a lac operon, it's going to use, see this little purple thing? That's lactose, and what lactose basically is, I mean, it'll come from things like milk or like other dairy products. So that's why lactose intolerant people, they can't drink milk and stuff, because it means that their body, the lactate in their body, which it's named lactase, I guess, lactase, I'm not really sure which one it is, but that's just an enzyme that breaks down this lactose. So lactose intolerant people, I guess they don't have the enzymes that can break that down. So anyways, what's going to happen is when this is positive regulation, which basically means that when the repressor is here and there's no lactose in this little binding area, the RNA polymerase cannot bind, cannot go to the starting line. It won't work. Like if it tries to go on the promoter, it just can't go because the repressor is blocking it. So what's going to happen with this, since it is positive regulation, this lactose is going to bind right here. Once there's enough lactose in the body, it's going to attach right there, moving the repressor, which is then going to allow the RNA polymerase to go and read the DNA. And then, it'll do everything else that I talked about with translation and all that stuff. So, that's just a way of gene regulation in prokaryotes. And let's go to the, oh man, is it the trip operon, the terp operon? I don't know, but let's go on to that now. Alright, so this is tryptophan, this little purple thing, and this is the trip operon, however you say it. It's much like the lac operon in that promoter, operator, structural genes. It's the same type structure, I guess. And this is the DNA, the little swirlies. So the promoter is going to do the same thing as in the lac operon. It's where the RNA polymerase is going to, it's the starting line. Operon, where the repressor is. Basically, that's all the same. The thing that's the biggest difference is that this operon is a form of repressible or negative regulation. So it's kind of the opposite of the lac operon. So what's going to happen is, for the lac operon, when the repressor was binded to the operon with the lactose in it, when the repressor was bound to the operon without the lactose, that's when the RNA polymerase couldn't bind to transcribe all this. But for this operon, I'm not gonna say this. Sorry, I'm a wreck today, man. For this operon, it's the opposite in that the repressor, the RNA polymerase isn't going to bind when the repressor is in the operon with the tryptophan, which is an amino acid. It's represented by this purple thing, when that's in the operator. I hope that makes sense. So, much like the lac operon in reverse. Once this tryptophan leaves, this repressor is going to leave, and then RNA polymerase is going to be like, hey, now I can read. He puts on his glasses and then go ahead and we'll transcribe all that. So that is the terp, whatever, operon. Alright, so this is a model of eukaryotic gene regulation. This right here is going to be the enhancer region. This little pink thing is the activator protein. It'll come down, and I'll show what happens when it comes down in a second. This is the regulator region. This is going to be the regulatory protein. This is the TATA box. I'm not exactly sure how to say it. I'm just going to go with TATA. This is, I'm not really sure how to say this either, TFIID, I guess. Maybe it's TF2D. I'm not really sure. I'm sorry. These are transcription factors, and this is our good old friend RNA polymerase. Oh, and this little section right here is going to be the initiation site, but that's not really, I mean, I'm actually going to get rid of that. Alright, no, I'm not. It's too hard. Alright, so, I'll explain what everything does in a second, but first of all, the enhancer region and the activator protein, well, the activator protein is going to come down and bind to the enhancer region. Oh, and this orange stuff is DNA, by the way. Well, I mean, it's not really, but it represents DNA. But anyways, when that happens, the activator protein binds to the enhancer region. Oh, no! It's going to, alright, let's pretend that didn't happen. It's going to fold the DNA. So,
That's where I stopped it.
boom, the DNA has folded. This, ooh, let me get the pen. This pink thing is still the activator protein, and this is still the enhancer region. I know it was smaller before, but I did it smaller because I was trying to demonstrate that it was like way away in a galaxy far, far away. I'll show you my picture. See, the enhancer and the activator protein is all the way over here, and all this stuff is clustered over here. So that's why I made it bigger to show that earlier it was smaller because it was so far away. So I don't know if that was clear, but so the DNA has folded, but everything is pretty much still the same. Actually, I'm going to explain to you what things are. So, like I said earlier, this is the regulator region, whatever, and the regulatory protein. What those do, they just basically decrease or increase the expression of certain genes. That's basically just the basics. These transcription factors right here, the purple little P things, they're basically just proteins that help convert or like transcribe DNA into RNA. The promoter, I guess I'll show that. Oh, I forgot to add a repressor in here. 1 second. That's better. Poor little repressor got left out of there. So this is the TATA box, or the promoter, and this is the operator with the repressor, and then these are going to be structural genes. So, if those terms sound familiar, maybe it's because they were a part of prokaryotic, like the gene regulation, whatever, the lac operon and the other one that I can't say. So, what the promoter is going to do is, well, it's just basically the same thing in the lac operon and whatever operon. That's just where the RNA polymerase will be like, all right, here's where the getting started here. The operators, regulatory genes, it's all the same thing. Repressor, same thing. But the repressor is the opposite of an activator. So, for example, the repressor represses genes, while the activator, which is that pink one right there, it activates genes. So, I mean, basically, the activator will like activate transcription of a certain gene, and then so it'll increase the gene transcription of whatever gene, and the repressor prevents it. Like when the repressor is there, it can't be transcribed, or it'll lessen the transcription, whatever. So I'm a goofball today, kind of. I'm sorry. Oh yeah, enhancer. So this enhancer region up here, that is just basically just a segment of the DNA. It like binds with activators. So that's how it all comes together to help with gene expression. All these transcription factors, the RNA polymerase, it all contributes. The enhancer region, it's all like helps express certain genes. I'm sorry, you can probably tell, but my brain is like dead today. But they'll help express certain genes. So this repressor can be like, hey, don't transcribe this gene. Or this activator can be like, hey, transcribe this gene. I mean, I don't really know how to explain it very well. Basically, it all just works together to produce the genes that are supposed to be produced. And so that's pretty much eukaryotic gene regulation. Thank you very much. I'm sorry that I was not focused today. Thank you for being an awesome teacher. And I think that's it. Okay, bye. Ooh, let me write it because I feel like I love writing on aluminum foil. I hope I'm not wasting your time. I probably am. Okay, bye.
I apologize a lot.